Good morning, everyone. Good morning. Is it audible now? Are there any doubts from the lesson number 2? Just give me your response reply. If there are no doubts, we'll go for new lesson. No doubt. Yes. So I think very clear. We'll go for new lesson here. Today, I'll start a new lesson, that is acids and bases. Right? Here in a 7th class, we learned about acids, bases. Right? Acids, bases. Before that, you don't have any idea about the substances, right? In a 6th class, you learned about changes around us, changes in the substances nature, right? They are classified into temporary changes, so permanent changes, so man-made changes, so natural changes, so artificial changes, so like that. But when you enter into 7th class, second lesson, acids, bases. In that particular chapter, you learned that changes is here based on the nature. That nature turns into acid or base or remains with the same or completely it changes as neutral. Right? So simply for that we used a taste. For example, in your food, you are expressing the taste as a sour in taste, salty, spicy, right, sweet, bitter. So different tastes we are enjoying. Here, according to the taste, you are able to classify the substances, right? So mainly the classification of substances in 3 categories based on the property, taste of the substance. So here based on nature, right, especially on the taste, we are classifying that substances into 3 categories. What they are here? They are namely here as acid, base, and neutrals. Right? Acids, bases, and neutrals. Here, simply to classify them in these categories. On which property I depended especially on the property called taste. So based on the taste, here especially acid classification, the substance which are sour in taste, the substances which are bitter in taste, they are classified into bases, right? There is no particular taste. They are giving you different taste other than sour or bitter. Other than, they are called as here neutral substances. So here I got 3 types of classifications. What they are here? Ice, acid, base, and neutral. Simply here, can you give me example from your daily life for acids, bases, and neutral substances based on the taste? Anybody? Based on the taste. Acids, sour in taste. Examples for acids here. Right? So here I can give you that examples from the daily life. Lemon water, tamarind, orange, etc. So we can add many into our list. Right? These are all sour in taste. Lemon water, tamarind, orange, they are sour in taste. So based on the taste, I classified these into acids. Bases, bitter in taste. From our food, bitter in taste. What they are? Bitter gourd, cucumber, ridge gourd, etc. Right? You can add many into this category also. Neutrals, no taste, no particular taste, right? So here I give you two examples from your daily life. They are distilled water and the other is common salt, right? So these are the examples. To identify these substances as acidic substance or basic substance or neutral substance, what the characteristic property I used here? Can anybody, which property helped you to identify them in acidic or basic or neutral? Which characteristic property helped us? Anyone? On which property of the substance we depended? What characteristic property I used to decide or classify them into acid, base, or neutral? Are you following or not?
Taste.
It is
Taste.
taste. So here, every time, this method to decide the nature of the substance is the right way or correct method. Would you like to taste every substance? It may be known to you or unknown to you, to know the nature. Can anybody? Is it the right method to decide the nature of the substance as acidic, basic, or neutral? No. Why? Why it is no? Can anybody answer? Why?
Sir, some acids are harmful, sir.
Yes.
So we should use litmus paper.
They are maybe poisonous, harmful to our body, right? So due to that reason, we are not depending on this method. So instead of taste, we need to use another characteristic property to find the nature of the substance. Then how to find out that nature of the substance here, right? Without tasting them, because I don't know the nature of the substance always by the taste, or that nature, okay, I will decide by the taste. I don't know, is it good for our health or harmful to our health? So I won't use this method always. Only in the food substances it will help you. What about the chemicals? How do you decide the nature, right? So for that, we are using indicator, that which gives us information regarding nature of the substance as acidic medium, basic medium, or neutral. What is actually here indicator, right? So here our concept is about indicator. Can anybody know what is meant by indicator here? What is the meaning of indicator here? Meaning of indicator. Indicator meaning. Don't know? If you don't know, respond. Here, indicator is what? Simply it is a substance, right? That which changes its color in acidic medium or basic medium or in the neutral, right? So here, that substance we can use as indicator here, that which can change its color. Substances which show the acidic basic behavior of other substances by changing its color. So they are called as here indicators, right? Here, what is actually indicator? It is a substance which hides itself acidic or basic nature. They are weak. Indicators are what? Weak acids or weak bases. Itself it is a weak acid or a weak base, and itself it change its color if they are combined or added into other substances. Are you clear now about indicator? Have you got meaning? What is an indicator? It is a weak acid or a weak base. Then when we add these substance into any other different material or the liquid, right, then it can change its color into other. By using that color, we are identifying the nature of other substance, right? So which are used as indicators here? What are the types of indicators are there? Okay, so here which are used as indicators? Itself, it is a weak acid or weak base that which has this nature that can be used as indicator. Then what are the types of indicators are available here? Mainly we have here 4 types of indicators. Can anybody name them? 4 types of indicators. Anybody name that indicators? Types. No one? No one? Here the types of indicators are here. Simply there are 4 types of indicators, right? How many? 4 types of indicators. They are natural indicators. Natural indicators. In the natural indicators only, one more is there. It is olfactory indicators. Then we have laboratory indicators called synthetic or artificial indicators, right? And one more is universal indicator in synthetic category only, right? So these are the 4 types of indicators. Did you know that these 4 types of indicators? 4 types of indicators. How many of you know these 4 types of indicators? Yes, Rampoli, Sri Charan. So no one. Okay, except Sri Charan. So here these are the 4 types of indicators: natural indicators, olfactory indicators, synthetic indicators, and universal indicators. So here natural indicators, which are called as or which are named as natural indicators, simply natural. From the natural resources, if any indicator used or collected weak base or weak acid from them, natural sources, maybe plants or maybe animals at extract, right? We are collecting that sample from the animals or from the plants. If you use that indicators obtained from the natural sources like plants and animals, they are called as natural indicators, right? For natural indicators, we have examples, litmus papers, right? In 7th class, you learned natural indicators other than litmus papers. What they are? Here, turmeric powder, right? Turmeric powder, red cabbage juice, right? China rose, hibiscus, China rose only, hibiscus, right? So here, these are examples for natural indicators. So litmus, turmeric, red cabbage, right? China rose, also called as hibiscus, right? So these are example for natural indicators. Olfactory indicators, what is meant by olfactory here? Simply it gives meaning order. O-D-O-U-R. O-D-O-U-R. What is odor? Means smell. So based on the smell also, you are able to decide the nature of the substance, right? So here the substances which change its smell, right? Indicators that which or change their smell in different mediums, they are called as here olfactory indicators, right? As olfactory indicators, we are using natural resources only. They are here onions, clove oil, vanilla essence, etc. Right? Onions, vanilla essence, clove oil. These are we are using as olfactory indicators. Then we have one more, artificially prepared in the laboratory or prepared by using chemicals, combination of many. They are called as here synthetic indicators. Here universal indicator also comes in that same category, synthetic or artificial, or these are also called as laboratory indicators. What they are called as laboratory indicators. Okay, so here what are here laboratory indicators? they are prepared by using the different chemicals, right? Indicators that for synthesizer in the laboratory, especially in the laboratory. Here, synthesized in the laboratory, they are called as here synthetic indicators. Synthesis means process. They are processed, directly not obtained. By the process, they are prepared. So they are called as here synthetic indicators. They are here mainly phenolphthalein, methyl orange. There are two types of indicators in the laboratory indicators. Synthetic indicators called methyl orange and phenolphthalein solution. Right? Then universal indicator is there. It is useful for any nature, for acid, base, or neutral. So using a simple paper, we are identifying the nature, and also we are identifying the strength. That means acidic character concentrate, how it is, right? That strength also we are knowing by using this indicator. Indicators use it to get the strength, isolate nature. Both we will get, or both we will find by using the universal indicator. So as universal indicators, we are using pH paper, right? As universal indicator, pH paper. So natural indicators, litmus paper, turmeric, red cabbage, only from the plants and animal extracts. Especially we are depending on the plants, right? Plants. In that, flowers are the best, petals. From them, we are collecting the pigment that we are using as indicator. Olfactory indicators, onions, vanilla essence, clove oil. Synthetic indicators, methyl orange, phenolphthalein. Universal indicator, laboratory indicator. Now, have you got clarity about indicators? Yes, everyone. Have you got clarity? Are you clear about indicators? Right. So here, indicators. Just it is showing something, indicating you symbolically. That symbolically what we'll get here? Color change. So we need to notice the color change, right? So by the many observations already they are generalized that are colors, right? So that colors we are observing here, right? Indicator colors. How do they behave? How do they change their color in different substances? So here we are especially dealing in this chapter litmus papers, methyl orange, and phenolphthalein. We are dealing mainly with these three, right? Litmus papers, methyl orange, and phenolphthalein. Here litmus papers are available in two colors. Methyl orange, originally its color red orange, right? Orange red or red orange. Then phenolphthalein, colorless, right? Phenolphthalein is colorless. Methyl orange, orange red, and phenolphthalein is litmus papers are available in two colors. What they are here? Blue litmus paper, and the other is red litmus paper. So we have two types of litmus papers: red litmus paper, blue litmus paper, right? Then we are observing the change in the color of blue litmus paper into red, red litmus paper into blue. So they can exchange their color. Blue changes into red, red changes into blue. So if there is no change, we can decide the nature of the substance as neutral. Red remains as red, blue remains as blue. So that we can decide as neutral substance. Right? Here, simply look at here. Blue color litmus paper dipped into first beaker. That blue changed into the red color. So what the nature adopted by the liquid solution is, that is here acidic. Blue litmus changes to red in color. It indicates the nature as acidic. The nature of the substance is as acidic. If that red litmus paper changed into blue color, what is the nature? It is basic. Red changes into blue, it is basic. Red litmus turns into blue color. It indicates the nature of the substance as basic. So here these are the observation. If nothing is changed, no change in litmus paper's color. Then what is the nature? Any litmus, it may be blue or red. Blue remains as blue and red remains as red. So we can decide the nature as neutral. Now, have you got idea about litmus paper and their observations? Did you got experience with them? Right. So these are about litmus papers and observations in the acidic medium, basic medium, and in the neutral substance. Right. Here, look at what happens when I add a solution into the acidic medium and into the basic medium. Observe clearly what I added. What I added. What I am adding. Acid, base. I used a liquid to drop them into the acidic medium and basic medium and observe the color. Can anybody guess what I added here? Can anybody? What I am adding? No one? Here I added, it is simply said to be dye. What is color? How I prepared that color? How I prepared that color? From the plant's extract. Right? That is what litmus solution I am using here. Litmus solution I am adding using the dropper. What I added? Litmus solution. How do you prepare litmus solution? From the plant's extract. That is here which belongs to Phenolphthalein division, lichen, plants, lichen, that which belongs to Phenolphthalein. Right? From that we are extracting this liquid called as a dye, right? Liquid solution that I added. It is nothing but litmus solution. We can use litmus paper or litmus solution, anything. Here litmus solution using means you can observe the same colors. Litmus papers, automatically that paper turns into another color. Okay, clear? Have you got idea about litmus solution? Yes. Okay. So now we will change the concept here. So you got experience about the litmus papers and litmus solutions. Now I'll take the concept that is methyl orange here. Methyl orange is a solution which is available in the orange or red orange color. Right? Not completely red, red orange. So this is methyl orange solution. We can add that methyl orange solution into the acidic medium, basic medium, right? So here it can identify the nature, acids, bases, and neutrals. Methyl orange turns into red color. Methyl orange turns into red color. It indicates the nature as acidic, right? Methyl orange turns into red color. It indicates the nature as acidic. If that methyl orange turns into yellow color, it indicates the nature as basic. Look at them. How to identify. So if you add that methyl orange using dropper into acidic medium and in the base, also called as alkali, Alkali meaning is the base which dissolves in water. The base which dissolves in water called as alkali. That's why here I taken alkali name. Base dissolved in the water. Here you are able to find out nature of any substance when they are in liquid form. Right? When they are in liquid form. In the liquid form only, they can give their behavior as acidic medium, basic medium, or neutral. Without that liquid form, you cannot find the nature of any substance. Right? So here, acid, methyl orange turns into red color. In base or alkali, that methyl orange turns into yellow in color. So these are the observations with methyl orange. Then next thing is phenolphthalein. Phenolphthalein is a colorless solution. Phenolphthalein is a colorless solution. If you add that phenolphthalein into acidic medium or into the neutral substances, you can find that color of the phenolphthalein without any change. That means solution remains in its own color because you are added phenolphthalein solution, that itself colorless solution. So if the solution added by phenolphthalein remains in its own color or remains as colorless, then the nature you are unable to decide as acidic or neutral. There is a contradiction. It may be acid or neutral. Don't say if the colorless solution directly given, right? Directly given unknown nature. Suppose I am given something solution to you. If you add phenolphthalein, what is the nature of the substance? How do you decide on it? For that question, I can answer if that solution remains with colorless, it may be acid or neutral. If it changes into pink color, that sometimes give you red also, right? That sometimes give you red. So red or pink, that we will decide as basic. Right? These are we are deciding as basic. Are you clear about the indicators? Complete idea about indicators. Have you seen them? Right. So just little bit idea. Practically you are experiencing as you did, right? So just keep it in your mind. Visualize them, how they are behaving in different mediums. So phenolphthalein is a colorless solution in acidic medium and basic medium. That solutions remains in its own color or remains colorless after adding phenolphthalein also. In a basic medium, if you add phenolphthalein, that color of the solution turns into red or pink. In methyl orange, that neutral substance remains as methyl orange color, but in acidic medium, it changes into red. In basic medium, it changes into yellow. Then two litmus papers are there, blue into red or red into blue, it can change. Or if that blue remains as blue, red remains as red, then the nature is decided as neutral. Blue changes to red, acid. Red changes to blue, basic. Right? So these three are used as indicators here. These three we are using as indicators. So these water litmus papers, methyl orange, phenolphthalein are useful to find the nature of the given substances. Right? So these are about the introduction part of your lesson. They are given in the starting page, page number 33. Now completely you got idea about your introduction page, introduction of the lesson completed. Everyone, have you got idea about introduction of the lesson? How do we decide the nature of the substance? Using the indicators. Why not directly taste? Because sometimes maybe they are harmful. We don't know the nature of the substance. So that is the reason for using the indicators. That is the reason for using the indicators. Right? So we'll go to another topic. Here it is about chemical properties of acids and bases. So we got idea which are here acids, which are here bases, which are here neutrals. How to classify them with the indicators, right? So that knowledge we are using to know the properties of the acid, base, and the neutral substances in this lesson, right? In the first activity, you are just observing the response of the different substances. Maybe it is acidic or basic, right? How do we decide? Using various laboratory substances with the help of indicators. Laboratory substances means they are chemicals here, salts, right? It may be liquid or maybe the salt. So if you take or if you collected liquid, there is no problem. If you collect a salt, prepare aqueous solution of the salt, right? Then what are the samples we need to collect that are suggested in your activity 1? They are as here well known or what we are using number of times, right? So that samples only here named, that samples only here suggested us to collect. What they are here simply HCl solution, sulfuric acid solution, nitric acid solution, acetic acid, sodium hydroxide base, potassium hydroxide, magnesium hydroxide, ammonium hydroxide, and calcium hydroxide. So these are the laboratory substances here used as samples. These samples collect. Then along with them, you need to have an idea about the behavior of these substances or response of these substances with the indicators. What the indicators we know? Litmus papers, blue color, red color, both available. So we can use red litmus paper, blue litmus paper. From synthetic indicators, methyl orange, phenolphthalein. So I'm using these indicators to observe that indicators behavior. I'm making a table like this, right? So serial number, substance or sample, then red litmus paper, blue litmus paper, methyl orange, phenolphthalein. So these are we are using. These are we are using. Clear? These are we are using. Okay. So we will see the response of these chemical substances, right? Chemical substances. What the chemical substances we are namely collected? They are here HCl, H2SO4, HNO3, CH3COH, acetic acid. I'm saying the names also. Hydrochloric acid, HCl, H2SO4, sulfuric acid, HNO3, nitric acid, CH3COH, acetic acid, right? Then CH3COH, also known as vinegar. Then NaOH, caustic soda. NaOH, caustic soda, sodium hydroxide, potassium hydroxide, magnesium hydroxide, or called as milk of magnesia. Next, NH4OH, ammonium hydroxide. Finally, calcium hydroxide. Right? These are the solutions. These are the solutions. Right? So, what are the sample solutions you are collected? Then observe these substances responses with the different indicators. Right? So let us see that responses in the next class. Join immediately because this time completed. Join immediately. Thank you.